Again, welcome to DSRT 734 class, Inferential Statistics in Decision Making. These lectures cover analyzing group data. So our main objective is to go through how to analyze group data. So what is a group data? So far, most of the data or the measurements that we have done covers an individual data. So all of the statistics measures we have discussed so far presume that individual data measurements are readily available. For example, we have a student that take 3 exams. We want to find the average or the mean of the 3 exam scores, or the media or the mode of the 3 exam scores. Since this is an individual scores, we consider this as individual data measurement. However, there may be instances in which only a frequency distribution of data is available. So for example, we have 20 patients visit an hospital. Then we may say that, okay, patients that their blood pressure is between 100 to 120 are 5. Patients that their blood pressure is between 121 to 130, they are 3. So now, since we have a data, not a specific, for example, one patient blood pressure is 121. But here we are saying between an interval. So we may consider this as a group data. So here we say when data is presented in that form, it is called a group data. Now, it's very important to be able to compute measures such as the mean and the standard deviation for this type of data. We should note that because the raw data observations are not available, the measures will be approximate. So we have 20 students, different scores. Now, if we are very specific that the first student score is 20, the second student score is 50, this is an individual data. Now, if we say we want to find how many students score between 20 to 50 and between 51 to 70, now this will be a group data because maybe we may have 4 students that their score is between 50 to 70, but it's not individual, not specific score for each. So here we need to consider the frequency. So how do we find the mean of a group data? Here we said the population mean of a group data is given by the sum of Fi, Mi over N. So N will be the population size. Now F will stand for the observations, the number of observations. So here we say Fi will be the number of observations in the ith class. Then N is the total number of observation in all classes. So that will be the total population. Now, when we say in I class, we mean, again, we talk about weight between 100 to 120. That's the first class. Between 121 to 130, second class. Between 131 to 140, etc. So that's why we say Fi will be the number of observation in ith class. Then the Mi will be the midpoint of the ith class. So if we have between 120 to 130, the midpoint will be the average of the lower and upper values. So we are, instead of using individual values, here we are going to use the midpoint and also the total number of observations. In this case will be Fi. So the midpoint again will be, let's say 120 plus 130 divided by 2, which means 120 is the lower value and 130 is the upper value. Then if we want to find the variance of a group data, same thing will be same concept. Now, instead of saying each individual value x1 minus the mean all square plus s2 minus the mean all square plus s3, etc., which is what we did previously. Here we are finding the variance of a group data. So it will be the midpoint value 1 minus mu all square times how many of them in that group or that class. divided by the n. Again, we are going to see an example soon. So that's the corresponding formula again. Now, to find the actual value, the computation formula for the population and the sample variance of the group data are as following. So we have again the sum of Fi against the frequency or the total tally of each class times mi all square minus, we find the average Fi, sum of Fi mi all square divided by n, or divided by n also. So this will give us the final formula. Now we know that if it's a sample size, instead of n divided by n, we divide by n minus 1. So let's see example. I think that will help us more. So here we have a table that represents the systolic blood pressure reading of 85 patients in a group form. Why is it in a group form? So here we can see that we have interval from 106 to 115, we have only 2 patients. 116 to 125, we have only 5. 126 to 135, we have 13. Now the interval must be the same width. So from here, as we said earlier, first we need to find the m. The m for the first class will be 106 plus 115 divided by 2. The m for the second will be 116 plus 125 divided by 2. And we keep going. Then we multiply the m value with the f. So that's what we have here. To compute the mean and standard deviation, first thing we need to do, the midpoint of each interval must be calculated. Then the class midpoint is determined as following. So the lower class boundary plus the upper class boundary divided by 2. So as we said, the first class, from the table, we are going to get 106 plus 115 divided by 2. Then if we know the midpoint, from there we can also calculate almost all the, so first again, this is the blood pressure, systolic blood pressure. We find the midpoint was 110.5 because we have 105.5 plus 115.5 divided by 2. So after we get the midpoint finish, we multiply by the frequency. The frequency is how many, actually that is given to us. If we look at the original table, the first is the frequency is 2. So only 2 patients have systolic blood pressure between this interval, 106 to 115. Now, instead of writing 106 to 115, we normally reduce it by 0.5. So we have 105.5 to 115.5. So we had 105.5 plus 115.5 divided by 2, and that gives us 110.5. Then we multiply each m class by the frequency. Then we find the total tally for F1 or Fi times Mi, which will be F1 times M1 plus F2 times M2 plus F3 times M3, etc. Since we are going to find the variance, we also need the Mi square. So we square the midpoint values and we multiply by the frequency and we have the total. So now we have to plug the formulas. So to find the mean will be the sum of Fi Mi over n, which we already have the sum of Fi Mi is here given to us. N will be the total frequency, which is 85. So we have 13,052.5 divided by 85. Then we can also find the variance. And this is our formula. We already have the sum of Fi Mi square in our table. Let's go back again. We find the Fi multiplied by Mi square. And we have sum all together. This is our sum. So we are going to plug that value in the formula. So that will give us over 2,045,135.25 minus the sum of FIMI all square. From the table, it was 13,052.5 all square divided by n. Again, n is 85. So when we do this arithmetic operation, we get 480. So here we say again, to find the population standard deviation, we will take the square root of the variance. So we can see that the formulas are almost the same as we covered the individual data before. How to find the mean, how to find the standard deviation variance. The only thing here is that we have to consider the frequency, because here we have a group of data. For example, in the blood pressure here, we can see that it's difficult to tell from the table. We don't know if there's two patients here. Their blood pressure is between 106 to 115, but we don't have the actual data. If we have actual data for each of the two patients, then this become individual data. So that's the whole concept of a group data. So in this case, we have to consider the frequency in each class. So that would be the example we have here, and that's the conclusion of these lectures. Again, if you have any question, feel free to send an email or during the class section, we can go through. Again, let's look at the formula one more time to make sure. So this is a group data. We can see that the mean will be FIMI, the sum. So let's say we are assuming I is the classes. So if the group data, we have 4 different groups, then we have F1, F2, F3, F4. Same thing, we're going to have M1, M2, M3, M4. So we sum everything divided by the population size. Now, to find the variance, individual data means what? Take individual value, subtract the mean from its square, and divide by n after you sum all the individual values. But here we are using groups, so we use MI minus mean all square times F1. The frequency, let's say F1, the first class, M1 also be first class, so difference. So that will be the conclusion of these lectures. And again, wish everybody the best.